The next couple of videos are going to focus around special right triangles. In particular, the focus of today's discussion is going to be on the isosceles right triangle. Now, by virtue of the fact that this triangle is isosceles, it has to have a pair of congruent sides. By virtue of the fact that this triangle is a right triangle, it also has to have a right angle. Since the hypotenuse has to be the longest side in any right triangle, it must be the two legs that are going to be congruent to each other. So in looking at this picture here, we have two legs that are congruent to each other, x and x, and we've got this hypotenuse opposite from or across from the right angle. Now, by virtue of the fact that the legs are congruent, we also know that the angles opposite those legs are congruent. And because those angles together have to be complementary, we know that those angles have to sum up to 45 degrees. So while sometimes this triangle is called the isosceles right triangle, sometimes it's also called the 45-45-90 right triangle. So there's a little bit of background or some things that you should already be able to put together based upon your knowledge of right and isosceles triangles. Really, the new idea for today tells us that the length of the hypotenuse is always going to be equal to the square root of 2 times the length of either leg. So that's really the important key piece of information for today. In other words, if you want to think about it in terms of a ratio, the lengths of the three sides of the triangle are in the ratio of 1 to 1 to root 2, where the 1 and the 1 represent the lengths of the legs, and the root 2 represents the length of the hypotenuse. All right, so let's go ahead and look at how we can apply this into solving some problems. Notice that it says exact answers only. So what that tells us is that they don't want decimal approximations. They want our answers left in simplest radical form. All right, so in the picture, I'm going to go ahead and start by marking my two congruent angles and my hypotenuse. So 10 is going to be the hypotenuse. These guys are going to be my two congruent angles, which means x and y are going to be my two congruent legs. Once I find one of them, I'm going to know the other. Well, if I go back up to the middle of the page where I highlighted this, the hypotenuse equals root 2 times the leg, I'm going to think about that as my formula. Hypotenuse equals root 2 times the leg. All right, so I can take either one of the legs. They're both congruent to each other because this is an isosceles right triangle. I know my hypotenuse is 10. My leg is either x or y. And then I'm going to solve this equation for x. To undo multiplying by root 2, I'm going to divide both sides by root 2. So when all is said and done, I end up with x equals 10 divided by the square root of 2. And since those legs are congruent to each other, I know the value of y must be equal to the value of x, and it must be equal to 10 divided by root 2 also. Excellent. I'm going to move on to the next one and erase these markings over here that the ghost has drawn in there. Again, you may find it helpful to mark the congruent angles, to mark the congruent legs, and to identify the hypotenuse. And again, my little formula here, the hypotenuse is always going to be equal to root 2 times the length of whatever a leg is. So just like the first example, in this particular case, my legs are x and y, so I can substitute either of those two in for the leg because they're both the same. So my hypotenuse here is 14. And again, to undo multiplying by root 2, I'm going to divide both sides by root 2. So x, my leg, which is really the same as y, is going to be equal to 14 divided by square root of 2. Moving on to the next example, and looking at this one, I've got, again, the isosceles right triangle. I'm going to draw the congruent angles and the congruent legs. And again, I'm going to remember that little formula. The length of the hypotenuse is always going to be equal to root 2 times the length of either leg. And I guess this time, just to be different, instead of using x, I'm going to use y. Oops, and I want to go back. I want to plug in 8 root 8 for my hypotenuse. To undo multiplying by root 2, I'm going to divide by root 2. And this one's kind of interesting example because I'm going to have to do some division of some polynomials. A root 8 divided by a root 2 is going to be a root 4. So this is 8 times the square root of 4. However, the square root of 4 is just another name for 2. So this becomes 8 times a 2. And my y value ends up equal to 16. And again, my x value is going to be the same as my y value. So that one was a little unique and a little interesting and a little different. Okay, last one. Again, I'm going to mark all my congruent angles, mark my congruent legs, identify my hypotenuse. And really, the key piece of information I have to know for this question is that the length of the hypotenuse is always equal to the square root of 2 times the length of the leg. So 11 is equal to root 2 times either x or y. Doesn't matter which one you plug in because they're both going to be the same. So the value of x is 11 divided by the square root of 2. If they had said find that to the nearest tenth or to the nearest hundredth or to the nearest integer, then I would grab my calculator and I would punch that in and round it to the nearest whatever decimal place it asked me to round it to. But in this case, they're specifying exact answers, and that means that no rounding is allowed. All right, like always, I want you to take a few minutes, think about what the important ideas are in this video, take some time to reword it in your own words so that it's meaningful and useful to you, and then see if you can apply that information to solve the problems on that page.